Welcome back, children. Next topic is algebra of real functions. What do you mean by real functions? Real function means a function whose range is either set of real numbers or subset of it. Range and domain, both. Domain and range of a function is either R or subset of R, that is known as real function. Then we have to learn algebra of real function. So let f is a function from x to r and g is another function from x to r, where this x is a subset of r. Okay, this r means set of real numbers. Then first one, addition of two real functions. Addition means, look how to define addition. F plus g of x, that is also a function from f is from x to r, g is another function from x to r. So f plus g is also a function from x to r, and it is defined as f plus g of x is equal to f of x plus g of x for every x. For every x belongs to which set? This x is in the domain, belongs to capital X. Okay, so f plus g of x is defined as f of x plus g of x. Now the subtraction of a real function from another. So f minus g, that is the subtraction of g from f, that is also defined as a function from x to r. Since f is from x to r, g is also from x to r, f minus g is also from x to r, and it is defined as f minus g of x is equal to f of x minus g of x for every x. For every, I can denote like this, it's the notation, for every x belongs to x. Now the third one, multiplication by a scalar. Multiplication by a scalar. So f is a function from x to r, and let alpha be a scalar. Scalar means it's a real number, that's all. Then alpha f is also a function from x to r, defined as alpha f of x is equal to alpha into f of x. For every x belongs to r. This dot denote product into. So if it's a function from x to r and alpha be any real number, then alpha into f is also a function from x to r, defined as alpha f into x, alpha f of x, that's equal to alpha into f of x for every x belongs to r. Now multiplication of two real functions. F is a function from x to r, g is a function from x to r. Then we can define f into g. Okay, f into g is also from x to r, defined as f into g of x is equal to f of x into g of x for every x belongs to capital X. This is the definition of the product, multiplication of two real functions. After this we can do example, so it will be clear for you. Now the next one is quotient of two real functions. F is a function from x to r and g is another function from x to r. Then we can define f by g, that is also from x to r, defined as f by g of x. F by g of x is equal to f of x by g of x, provided g of x cannot be 0. If denominator 0, it is not defined. And for every x belongs to capital X. So f by g of x is defined as f of x by g of x denominator cannot be 0. So these are algebra of real function, that is addition of two real functions, subtraction of two real functions, then multiplication by a scalar, then multiplication of two real functions and quotient of two real functions. Now we can see the example question. Let f of x is x square and g of x is 2x plus 1 be two real functions. Find f plus g of x, f minus g of x, f into g of x and f by g of x. So first one, f plus g of x. How it is defined? According to the algebra of real functions, it is defined as f of x plus g of x. Okay. So what is f of x? It is x square. What is g of x? 2x plus 1. Okay. Or I can write x plus 1 whole square or keep as itself. That is f plus g of x. Now the next one is f minus g of x. It is defined as f of x minus g of x. Okay. So that's equal to x square minus 2x plus 1. That is x square minus 2x minus 1. Now third one, f into g of x. F into g of x is defined as f of x into g of x. So x square into 2x plus 1. Open the bracket, 2x cube plus x square. That is f into g of x. Now the last one, f by g of x. F by g of x is defined as f of x by g of x. F of x is x square by 2x plus 1. Okay. Can keep as itself and this denominator cannot be 0. So 2x plus 1 cannot be 0. Or x cannot be minus 1 by 2. Anyway, you can write either x not equal to minus 1 by 2 or 2x plus 1 not equal to 0. Now the next question. Let A set 9, 10, 11, 12, 13 and f is a function from A to n. N means set of natural numbers. Be defined by f of n, the highest prime factor of n. Find the range of f. So f is from A to n. So the domain must be equal to A. We have to find the range of f. So you have to find for each one, you have to give n as 9, 10, 11, 12 and 13 and find the corresponding value. So what is the value of f of 9? F of n is defined as the highest prime factor of this n. Whatever in the bracket, its highest factor you have to write as answer. So for this 9, what is the highest prime factor of 9? The prime factor is 3. Okay, factors of 9 are 1, 9 and 3. Prime number is only 3. So that is the highest prime factor. Now f of 10. Which is the highest prime factor of 10? That is 5. Only 1, 10, 5, 2 are the factors of 10 and the prime factor is highest one. 2 is a prime number, 5 is also a prime number. The highest one is 5. Now f of 11. 11 is a prime number itself. The highest prime factor is 11 itself. Now f of 12. Factors are 1, 2, 3, 4, 6, 12. The highest prime factor, which is the highest prime factor, it is 3. Then f of 13. 13 is a prime number. Highest prime factor is 13 itself. Okay. Then what is the range? Range means set of y values or set of this answer. The answer part is known as range. So range is equal to 3, 5, 11, then 3 once again, then 30. So this is the range. What is the domain? Domain is 9. Set 9, 10, 11, 12, 13. That is A itself. What is the codomain? Codomain F is from A to N means N is the codomain. The second set is known as codomain, and here range is a subset of that codomain. Range can be equal or subset. So this is the range of F. Now the next one. Let F is equal to set of ordered pairs 1, 1, 2, 3, 0, minus 1, minus 1, minus 3. Be a linear function from Z to Z. Find F of X. So F of X is given in like a roster form. We have to find F of X. F of X is given as it is a linear function. So a linear function is of the form mx plus c, where m and c are constant. That we have to find. Okay, linear function is just like a linear polynomial. You have studied in smaller classes. Linear polynomial standard form is ax plus b. The same thing. You have to find a and b or m and c from this. Okay, so I can write since 1, 1 this belongs to F. The F is given like this set of ordered pairs. So this 1, 1 belongs to F. You remember this AB belongs to F means I can write F of A is equal to B, isn't it? Then B is known as image of A under F, or A is known as pre-image of B under F. So 1, 1 belongs to F means I can write F of 1 is equal to 1. F of this one is equal to the second one. Now substitute. F of X is mx plus c. So what is F of 1? F of 1 is m into 1 plus c, isn't it? And that is equal to 1 itself. So m plus c is equal to 1. Put equation 1. Now one more pair you can take. Either you can take 2, 3 or 0 minus 1. 0 minus 1 is easy since one element is 0. So again you can write since ordered pair 0 minus 1 belongs to F, I can write F of A. F of A means F of 0 is minus 1. Now substitute 0 in the function. F of 0 means here m into 0 plus c, that's equal to minus 1. That means c is equal to minus 1. M into 0 is 0 itself. So c is minus 1. So from first equation m minus 1 is equal to 1. Therefore m is equal to 2. Okay. So what about the function? We have to find, the question is find f of x. So what is f of x? Therefore f of x is equal to mx plus c, that is 2x minus 1. So that's the answer. That's a linear function. Now fourth one, a function f defined by f of x is equal to 2x minus 5. Write down the values. F of x is equal to 2x minus 5. First one, what is f of 0? Just substitute x as 0. 2 into 0 minus 5, that's equal to minus 5. Now second one, f of 7. 2 into 7 minus 5, that is 14 minus 5, that's equal to 9. Third one, f of minus 3. 2 into minus 3 minus 5, that is minus 6, minus 5, that is minus 11. Okay. Now fifth one, the relation f is defined by f of x is equal to x square if 0 less than or equal to x less than or equal to 3. That is, if x value is 0 to 3, the function is defined as x square, and from x is from 3 to 10, the function is defined as 3x. Then g is another relation. These are relations, it is not given as function. G is another relation, g of x is given as x square if x is from 0 to 2 and 2 to 10 it is 3x. Show that f is a function and g is not a function. So we have to prove f is a function. F is a function means every element has one and only one image, that we have to prove. So what is the domain of f? Domain of f is a relation, it is given. So domain of f is equal to, I can write, what about x values? X is from 0 to 10. Okay, domain is 0 to 10. 0, 1, 2, 3 up to 10. That is the domain of the relation relation f. Now what is the range? We can find the range. So for that you have to give the value. What is f of 0? Okay, what is f of 0? 0 means you have to give here x square, that is 0 square, that is equal to 0. Now what is f of 1? 1 square, that is equal to 1. F of 2, 2 square, that is 4. F of 3, 3 square equal to 9. Now 3 to 10 it is defined as 3x. So there also, here 3, here also 3. So both 3 we can give. F of 3 is 3 into 3 from the second relation. 3 into 3 is again 9. So here also 9. So image of 3 is 9. Now what is f of 4? F of 4 is 3 into 4, that is equal to 12. F of 5, 3 into 5, that is 15. Okay, like that. F of 6, F of 7, F of 8, F of 9, F of 10. F of 10 is 3 into 10, that is equal to 30. Now you check, is this relation a function? How can you check? All the element in the domain. Okay, every element in the domain has how many images? Unique image, one and only one image. For the 0, only one image. 1, one image. 2, only 4. 3, 9. Like that for every element in the domain. Domain is from 0 to 10 and all the element has one and only one image. So we can say that this relation is a function. So we can write, since every element in the domain of f, every element in the domain of f has one and only one image. Only one image. Therefore, f is a function. Okay. Now what about the second one? G. G is defined the same way it is defined x square and 3x. So I am writing here also domain of G, that is from 0 to 0, 1, 2 up to 10. X square for 0 to 2. So G of 0, G of 1, G of 2. 0 square is 0, 1 square is 1, 2 square is 4. Now the second part. Again from 2 to 10 the relation is defined as 3x. Okay. So again you have to give 2. So G of 2 from the second relation 2 into 3 or 3 into 2, that's equal to 6. Then g of 3 is 3 into 3, 9. G of 4, 3 into 4, 12. Like that. G of 10, 3 into 10, 30. Is this relation a function? Here one image for 0, one image for 1, one image for 2. Here again 6 is the image of 2. So how many images for this 2? 2 images for 2. That is first element repeats. If we write as ordered pair, we can write 0, 0, 1, 1, 2, 4, and again you have to write 2 with 6. So first element repeats, that means 2 images for 2, not a unique image. So we can say that this relation is not a function. So we can write the reason, since 2 has 2 images, therefore G is not a function. So f is a function but G is not a function. That's the question. Show that f is a function and G is not a function. F is a function since every element in the domain has one and only one image. But G is not a function since the element 2 has 2 images. So it is not a function. So only that means. Now find the domain of the following functions. What type of functions these all? It's a rational function, polynomial by polynomial, a function of the form p of x by q of x, that is known as rational function. So these are rational functions. We have to find its domain, not range, domain. Domain means set of x values. So how to find the domain of this rational function? This function is defined for all values of x except this denominator 0 at which all points. Okay? If the denominator 0, the function is not defined. So the denominator 0 at which all points, that you have to find, and that delete from the set of real numbers. So first you have to find at which all values of x the denominator 0. X square minus 8x plus 12 equal to 0. Factorize. Product 12 sum minus 8. So I can write x minus 6 into x minus 2. Okay. That means x minus 6 0 or x minus 2 0. So x I can write 6 comma 2. So at when x is 6 or when x is 2, this denominator becomes 0, isn't it? So domain means set of real numbers minus these two values. Since at these 2 points the denominator is 0, if denominator is 0, this function is not at all defined. So that these two numbers you have to delete from set of real numbers. So this is the technique for finding domain of rational functions. Now this one, x square plus 3x plus 2 equal to 0. Put denominator equal to 0. Now product 2 sum 3, I can write 2 into 1. So x plus 2 0, x plus 1 0, that is x is equal to 2 comma 1. Okay. So when x is, minus 2 and minus 1. So when x is minus 2, so when x is minus 2 square 4, 4 plus 2 is 6, 3 into minus 2 minus 6, so denominator 0. When x is minus 1, 1 plus 2 3, here minus 3, that is 0. So when x is these two values, the denominator is 0. So we can write domain as set of real numbers minus, put set symbol and write these two numbers, minus 2 minus 1. That is the domain. Now look the next one. Again rational function. Domain means the denominator. Put the denominator 0 first. So x square becomes 1, x is equal to plus or minus 1. So domain is equal to R minus set minus 1. When x is equal to 1 or when x is equal to minus 1, denominator is 0. That you have to delete from set of real numbers. Here put the denominator 0. Product 8, sum minus 9. Splitting the middle term. So what are the numbers? 8 and 1. Minus 8 into minus 1 becomes 8. Minus 8 plus minus 1 becomes minus 9. Now from these two we can take 2x outside. X minus 4 minus take outside. X minus 4. So x minus 4 into 2x minus 1 is equal to 0. That means x is equal to 4 and x is equal to 5. Okay. So domain. What is the domain? R minus set 4 and that is the domain of the function. So understood how to find the domain of rational function. Put the denominator equal to 0, find the values of x that you have to delete from set of real numbers.